Hello there. In this video, I'll show about this time series analysis I did. The goal is to just demonstrate and walk through the process of building a time series model, how to interpret it. You might like it, you might learn from it, you might just nod your head or already skipped it. So let's start. This is the model plotting at the end. We'll come to it, but let's go to the top and start from everything and very quickly. I will share this thing, notebook, you can have a look. So basically, there are these steps that we're going to look at, the environment step, setup, how they import the data, the EDA, what I did there, the actual building the model and evaluating, the forecasting, the plotting that we just looked at, and the summary that I will talk over. So the setup is not so much, to be honest. I just had to install PM SARIMA. This wasn't in Databricks. And I imported all the packages I'll be using. I imported the data from catalog and Databricks I created based on this data they provided us in this hackathon. But the data is available on this Mobi Bikes website as well. Yeah, I didn't talk about it much, but the data is Mobi Bikes data, and what we're going to do is predict the 2026, 2025 trip counts based on the earlier data. So here's the EDA. What I do, I look at the data. There are a lot of fields, but I'm focused on departure time as one time field that I choose, and the trip IDs, the ones I'll be using as counting the trips. The rest, I'm not interested in this analysis, only two. So here I look at the empty fields. In the empty fields, I see a lot of sparsity here, a lot of rows. I isolate them and notice that they're between these 5 months at the end of 22 and beginning of 23. I look at them further and I notice these numbers close to 52%. This 52% 9 is the non-null ones. Actually, close to 50% of the data in these months are missing. Yeah, also there are some other months that are missing data as well, but for this analysis, I kept them as there and not imputed at all, and yeah, we'll see at the end. So I prepare my data further. I look at it yearly, and I notice this clear problem before 21. There's actually no data. There's no data. So I continue. I'll drop those. I drop them here. Uh, yeah, sorry for that. So I prepare the time series data frame with the departure times and the trip IDs, and then I set the index to departure time for clarity, and then I resample my data and get their sizes of the trip IDs. Oops, sorry, that's happening here. So my resampling is daily, weekly, and monthly. Soon, very soon, right here, I'm plotting them. This is daily plotting. This is weekly plotting. This is the yearly plotting. You see, the pattern is actually there. The one in the daily, the one in the weekly, the one in the yearly as well. But as you can see in the yearly, it's not so clear. And there are not a lot of data here. So because of that, I didn't want to choose the yearly because it's course. Also, I didn't want to choose daily because I will predict the entire year and this is a lot of data. So I did choose the middle one, the weekly. So after choosing that, I train test splitted my data into what's before 25 and after 25 like this. So this one is used to build the model. This one is used to test the model. So here I identify the best model to build, construct it, and evaluate it. This is the same plot of the weekly data. So for the time series to be able to run, we need to have our data as stationary. It seems, sorry for this quick skips, but I hope it's clear. So This data doesn't seem quite stationary, but eyes are foolers. So we have this Dickey Fuller test function I have from one of our classes. I checked, and after running this test, this appears non-stationary. So I need to do a differencing. After doing one differencing, it's kind of always like a white noise. So this appears to be stationary, but I run the test again and very small p-value. Sorry, yeah, and then the stationary as well. So after that, what I use is I use the first difference data and then plot ACF for looking at autoregression. To be honest, there's nothing significant here. Maybe from this levels can be considered as well, but yeah, this ACF chart, also for PACF chart for the moving averages, they didn't give anything. I tried with these little things that I pump up, but they're not anything significant, so it couldn't be useful by this. So I had to try building model differently. Like then, like I use PM Darima. We'll see below. But yeah, it would be nice to have some perspective from here as well. So this is one thing I did. I looked up online and I liked it and I wanted to include. This is seasonal decompose function. What it does is that it gets the original series and breaks it into the trend, seasonal, and residuals. The model I built kind of does more to it. These residuals still have some patterns here, so, but yeah, still it's good one. See the seasonality pattern is here, like around the summer, bike trips are increasing, not so much surprise, but we need to catch more specific things. So the trend is here, trend is increasing, yeah, and there is started to decline, so that happens. Yeah, this is the seasonal decomposed result. This is the part that I use auto arima. What it does is it runs different models and tries to find the best one. So because I built a kind of complex model, complex settings here with a lot of data, this environment crashed many times. So what I did is I took notes of one run I run and some of the candidates and the selected model I had. So we're going to look at it below. But simply how I run it is that periodicity is 52 because I was looking at yearly patterns. Seasonal is set to true because there are obviously some seasonality in the data. Differencing of the seasonal, forced it to be 1, even though it wasn't necessary. But because this is a complex run, I noticed that model finishes without doing those checks. And like testing helped with um, setting this as 1. So training limits, I set it like this to not run too extensively, but even with this, the environment failed. In other environments, it could run, but anyways, this is the model I choose. 2, 1, 2, and 1, 1, 1 for the seasonals. Periodicity is 52. So one difference thing and the AR and MA values there. So here I build the actual model with the values that we just looked at. So this is the report of the model. The what I really like to look at for now is this plotting the diagnostics of this fitted model. What it does is it gives us these 4 visuals that plots the residuals, and this appears to be a very good model, to be honest, because residuals are errors. We want to extract all the patterns, trends, seasonality, anything, any correlation from this residual data, and this kind of supports it. So this is it's if you look at it, this is kind of like a white noise, not this. So this also, they are in the mean. These huge spikes are not so good maybe, but they're oscillating on similar levels, so it's not too much of a problem. But this one is a bit of problem. So this happens around the end of 22 and the beginning of 23, and this kind of supports the earlier thing I noticed. The almost 50% of data is not there, so that's an issue, and it's probably because of this. So if I looked at the plotting of the residuals, we see that it follows the normal distribution very well. So the orange one is our residuals, and the blue ones is the actual histogram. The green line is the theoretical standard distribution, like the bell curve itself. So this kind of supports that the model, like the residuals right now, are normally distributed, which is good, which means that our predictions will be more reliable, our confidence interval will be more reliable. These two are supporting the same thing, so ordering all the data and all the residuals. This line is the theoretical line, which is everything is perfect, and our residuals kind of follow them as well. And here we have some outliers. So few of them are there, but no problem. So if you look at the correlagram as well, this shows the correlation between the residuals. So no significant anything. So this also supports the model is good. There can be, yeah. For now, this is the as far as it goes in terms of deepness of it. So here I run the code to make predictions and then set it as index, set a confidence interval here, and save them in the variables in the series to use in the plot below. So here I plot them. I use the test data and the training data, and I plot them together with my predictions here. And the fill between part here is for the confidence interval. Let's look at the plot, the one at the beginning. So this is SARIMA model. We didn't use any independent variables to check, only time series and the trip data. If we look at it, we have our data, the actual data, the blue lines from 21 to 25, the training data, and we see that seasonality here again. And also here in 25, we have the yellow one is the actual data, and the dashed lines are the forecast. And the shaded area is our 80% confidence interval. So evaluating this, oops, sorry, the model performance is actually very good. Almost all the points are in the shaded area. This appears to be robust, and the seasonality is catched, and the model simply looks quite good. Here's one issue. You can see there is a clear deviation here, and the reason I have for that is like potential reason I haven't tested it yet, but it appears to be at the beginning of the year, and I think it can be due to the missing data around this timeline. So if you actually look at it, there is also this 1 month gap in the 24 as well, but I ignored it as I said before. We can impute or try to find the data, but Mobi didn't provide it, and I didn't want to work on any synthetic data on this raw model I'm building. It can definitely be perfected. It's already quite good. So if we were to have data, maybe the drop here could be interpreted as this drop as well. So maybe there was a drop here as well, but um, the lack of data doesn't show the reality, and the 25 data maybe assume that the one here is just error, so there's no clear pattern. But because the earlier year, the year of the beginning is actually a increase in the bike counts. So that could be one of the reasons, but we don't know. These are assumptions. Other than that, it's kind of good. It's really good. The statistical validation part in here, we looked at the residuals in the plot above in very detail. and the model itself and the plotting. This is kind of validates the model. The operational viability aspect is that this model definitely can be used to train at the end of the year to predict the 26 bike counts, and also it can be improved further. Obviously, when using it, it should be done under monitoring, continuous monitoring. But yeah, this is the model and how I build it and explaining the details of it. I think it should be useful while building it. I've definitely learned a lot, and I hope you learned something as well. And I hope this sharing means something. Have a good day, everyone.